Hello, this is Mr. Sakaguchi, and I'm going to be talking about standards 8 and 9 today. So, in standard 8, we were talking about creating chemical equations from sentences. So, let me give you an example of what I mean by this. So, let's say I give you the following sentence: iron, iron 2 oxide forms when oxygen, gas, and iron combine. Okay, so let's say I give you something like this. Okay, and when we're looking at a sentence like this, what we're really looking to do here is we're looking to identify our reactants and our products here. So one of the things we're going to want to do here is we're going to want to have our arrow. And remember, when we're writing out a chemical equation, things are going to go on the left-hand side and some things are going to go on the right-hand side of the arrow. So what I'm talking about here is identifying the reactants and identifying the products. So let's take a moment and let's see if we can figure out where our compounds are first. And once we find those, then we can use some additional information to figure out whether they're reactants or products. So I know iron 2 oxide is a compound or a substance, and I know oxygen is. The gas just tells you what kind of substance, so that doesn't really matter for the equation. And iron. So I've identified my substances. So now what I want to do is I want to identify action words that tell us where they go. So when I'm looking at something like this, I'm looking at words for like verbs, like forms and combines. Okay, and so the reason why this matters is because it'll let us know where things go. Okay, if something is forming, that means that we're making it, right? And if we're making it, that means that it has to be a product. So iron to oxide goes on the right-hand side of the arrow. And that means that if we're combining oxygen and iron, what that means is that they have to be reactants. So I have oxygen plus iron. And this isn't the answer, but I like to write out the word equation first before I write out the formulas, because I like to have what it is I'm gonna create formulas for. And the reason why this matters is because once I write it like this, it just becomes something a lot like from Unit 3, where we were going from names to formulas. So now that I have this, I can actually go ahead and put together my formulas. So I have my arrow, and let's do the easy ones first. Now we know that oxygen is not really O, it's actually O2. And remember, O2, the reason why it's 2 is because it's a diatomic, one of our diatomic elements, right? So when I say oxygen, I really mean O2. And if I'm talking about one of the other on your list, so for instance, if I say hydrogen, I really mean H2, or if I say fluorine, I really mean F2. Okay, and any of those on that list, if you see the name, you should write it out as with 2 atoms in the formula like I show you here. For iron, iron is just Fe. It's just a pure element. It's not on our list, so that's why it's written as such. And then the hard part is coming up with iron 2 oxide. Now that's the real trick here. Now this is a good opportunity to review how to name compounds here, or take a name and put together a formula. So here I have iron 2 oxide, and the first thing I ask myself is what kind of compound this is. And I can tell by the iron that I have a metal and then I have a non-metal, which means that I have an ionic compound. And once I have an ionic compound, I'm looking for positive and negatively charged ions so I can put together the formula. For iron, it's pretty easy. This is the answer, but these are the ions that I need in order to solve for the formula. So here I have iron, and because of the Roman numeral 2, I know that this is iron with a 2 plus charge. And the oxide is really the ionized form of oxygen, and this is O with a 2 minus charge. And let me just format this so it looks like it's supposed to. So these are the ions, and remember, when we're putting together ionic compounds, we want to combine them in such a way where the overall charge adds up to 0. And you can see that if we combine Fe and O together in a 1-to-1 ratio, it's balanced as is. Now I know what you're thinking. A lot of you guys are wondering, well, where's that other oxygen? And we'll deal with that when we balance the equation. But when you're doing these kinds of things, what I recommend you do, number one, is write the formulas first before you balance. Always balance last. Okay? The reason why this matters is because if you try and balance before you have the formulas, you're almost always going to end up with the wrong formulas. The natural tendency for a lot of people here is to put FeO2, which would be completely wrong, because we can see by the charges of our ions that isn't really possible. But we can account for the difference by balancing the equation. So when I put a 2 here, that means I now have 2 formula units of FeO, which means now that I have 2 oxygens, which balances the oxygens, right? But now I have 2 irons, but I can remedy that on the left-hand side by putting a 2 in front of the Fe. So now notice that the number of oxygens and irons are now balanced on both sides of the equation. And this is what we want you to be able to do. And I highly suggest that you look for your substances first, find your action words, put them, and use that to help you position where they should be in terms of whether they're reactants or products. And then once you have the names, you can go ahead and come up with the formulas of the compounds and then balance. Okay? So that was standard 8. And so let's move on to standard 9. And with standard 9, we were talking about the law of conservation of mass. So here we have our law of conservation of mass, and we basically stated that mass is neither created nor destroyed. And let me use an equation to kind of help illustrate this. So this is one you've probably seen in class, so I'm just going to type it out really fast because my typing is much better than my handwriting. And let me balance this first and format, so bear with me here, so that way it looks like it's supposed to. And I'll blow it up so you can see. And so what this reaction is describing is hydrogen and nitrogen coming together or combining chemically to form NH3, nitrogen trihydride, or you could say ammonia if you know the common name. And there we go. So here's our balanced equation. Okay, and so, you know, one way we've talked about how we can use the coefficients in terms of the creation of mole ratios and particle ratios to show how it satisfies the law. But one other way to do it is by mass, and you notice that we couldn't directly add up the coefficients to get the mass equal on both sides. But hopefully by now, with some of the stoichiometry stuff, what you recognize is that we can take the molar masses of these things, and they should be equal if we compare both sides of the arrow. So what I specifically mean, and we'll use this reaction as an example, if I take the molar mass of N2 and add it to 3 times the molar mass of H2, that should equal 2 times the molar mass of NH3. And so we can use what we know about the math in order to try this out. So let's go ahead and give this a shot here. So we know that the molar mass of N2 is equal to 28.02 grams, right? And then it would be 3 times the molar mass of H2, which would be 2.016 grams. And that should equal 2 times the molar mass of NH3, which is, let me look that up, it's a 17.034 grams. And so when we add these things up, remember the equal sign represents the arrow in case you were curious here. And when I add these up, let's see what I get here. On the one side I get 34.068 grams, and on the other side I get 34.064 0.68 grams. Okay, for those of you who are wondering where the discrepancy comes from, for honors, guys, we know that your periodic table says that the molar mass of H is equal to 1.008 grams, right? So this is for honors chemistry. But for chemistry, the molar mass, because you guys use a different periodic table, is 1.01. So if you're wondering if you're in the just the chemistry class, this is the difference. And we can use this idea to kind of illustrate that the sum of these things will equal the sum of these using the law of conservation of mass. And that is it for now. Hopefully you'll find this useful.